Now, after defining the concrete property, we are now going to define the rebar property, which is the steel rebar. To do that, we need to go to the define menu. You click on the define menu, then you click on material properties. So as you can see, we already have 4 KSI concrete. This was the concrete property we defined in lesson 1. So let's define the steel rebar. To do that, you need to click on add new material. So as you can see, the region still remains United States. Now this is where you need to change the material type. So you click on this drop down menu. In the previous lesson, in lesson 2, we used concrete because that was the concrete property, which was 4 KSI concrete. Now instead of concrete, it is going to be rebar. Now we're going to select rebar because we want to define the rebar property. Now make sure you don't select steel, because steel, this is for steel buildings, and we are not designing a steel building here. We are designing a concrete building. So make sure you don't select steel and make sure you select the rebar. So you click on rebar. Now we have the different grade of rebar. If you click on this drop down menu, you are going to see the different grade. We have grade 40, grade 60 and grade 75. So depending on the grade of rebar you are using. So we are using 60 KSI rebar. So meaning this is going to be grade 60 because we are using 60 KSI rebar. So if you are using 40 KSI rebar, it is going to be grade 40, and if you are using 75 KSI rebar, it is going to be grade 75. So we are using grade 60 rebar. So you click on grade 60. So you click on OK. So now you can name the rebar, the material name. So I'm going to name this grade 60 rebar. So I'm going to call this grade 60 rebar. Then the material type, as you can see, is rebar. Then directional symmetric type is uniaxial. Then the material note, you can write a note concerning the material, but we don't need that. So we have the material weight and mass. So this is the weight per unit volume of the rebar. It is 490 pounds per cubic foot. So if you use grade 60 rebar, which is 60 KSI, so this is going to be the weight per unit volume, and this is going to be the mass per unit volume. Then this is the modulus of elasticity, while this is the coefficient of thermal expansion of the grade 60 rebar. So if you click on modify show material property design data, we are going to get the yield strength of the rebar, the minimum yield strength, the minimum tensile strength, the expected yield strength, and the expected tensile strength. So basically the minimum yield strength is usually lesser than the expected yield strength, because this is the expected strength of the rebar. So it's going to be 66,000 pounds per square inch. But the minimum yield strength is going to be 60,000 pounds per square inch. Also for the tensile strength, it is 90,000 pounds per square inch. That is the minimum. While the expected tensile strength we expect for this rebar is 99,000 pounds per square inch. So I think that is okay. We don't need to change that. We click on OK. So I don't think we need to change any other value. Let's see, no linear material data. So we don't need to change this. Do not play with this. You don't need to change this. So click on OK. Material damping properties. So we also don't need to change this. The damping ratio is 0, so you don't need to change that. So just click on OK. Then we click on OK. So after that, as you can see, we now have grade 60 rebar. So we have defined the rebar property. Then after that, you click on OK. So now we have the concrete property and we have the rebar property. So let's now define the section property of the beam and the section property of the column. So this is the next step. We are going to define the section properties. To define the section properties, all you need to do, you need to go to the define menu. You click on the define menu. Then instead of material property, it is now going to be section property. So if you click on section property, we have different options: frame section, tendon section, slab section, deck section, wall section, etc. So because the beams and columns, they fall under frame section. We are going to click on frame section. So you click on frame sections. So now, as you can see, we have different properties. Now these W sections, these are all steel sections. So these are steel sections. So you don't need to worry about this because these are steel sections, and because we are not designing a steel building, we are designing a concrete building, so we don't need to worry about this. So this is concrete beam, this is concrete column, this is steel beam, this is steel column. So this is not what we're going to do. What we're going to do is we need to add a new property. So we need to create a new section property. So to do that, we are going to click on add new property. You can import new properties. So let's say you already have the template of the section property, so you can click on import new properties and it's going to import those properties. So let's say if you already define some properties, you can click on add copy of property, so it's going to copy those properties. So if you've already created some section properties and you want to modify and change those properties, you can click on modify show properties. So we are going to define a new property by clicking on add new property. So now, as you can see, we have the concrete section, we have steel section, we have special section, and we have steel composite section. So like I said, we are designing a concrete frame, so we are going to focus on the concrete section. Later on, we will discuss about the steel section when we design a steel building. So this is concrete rectangular, so you click on this. So as you can see, we have different section. We have the rectangular section, we have the circular section, we have the concrete T section, and we have the precast concrete I section. So this is not a precast section, so we don't need to worry about this, and we are not going to be using the concrete T section. So we're either going to be using the rectangular section or the circular section. So I'm going to be using the rectangular section. I'll click on rectangular section. So it is going to show us this window. So as you can see, it is asking us to input the depth of the section and the width of the section. As you can see, it is showing the dimensions in inches, and we are going to be using the dimensions in millimeter because the column dimensions is going to be 400 by 400 millimeter. So we are going to start off using 400 by 400 millimeter. So if it is not okay, maybe after we design the building it fails, then maybe we can increase the dimensions, but we need to start from somewhere. So I'm going to start with 400 by 400 millimeter, and this is going to be the dimensions of the columns. So because this is in inches, if you want to change this to millimeter, you can change this to millimeter. So let me quickly show you. So let me go back by clicking on cancel. Click on cancel. So to change the units, you need to click on units. Then after clicking on units, you are going to click on consistent units. So now the length units, let's input the length unit in millimeter. So because this is what we want, so we want the length unit in millimeter. So you click on OK. So let's go back defining the column sections. So go to define section properties, frame section, add new property, rectangular section. So here we have it. So as you can see, we now have millimeter instead of inches. So like I said, we are going to be using 400 by 400 millimeter. So the depth of the column is going to be 400 millimeter, while the width of the column is also going to be 400 millimeter. So this is basically a square column because as you can see, the depth and the width are similar. So we can name this property. So let me name this as column 400 by 400 millimeter. So the material type, if you click on this drop down menu, as you can see, we have a list of different material, and we are using 4 KSI concrete. So you need to click on 4 KSI concrete because this was what we defined earlier. So you click on 4 KSI concrete. So now let's click on modify show rebar. So if you click on modify show rebar, it is going to show you the design type. So we have two design type. We have PM2 M3 design, and this is for column, and we have M3 design only, which is for beam. So because this is a column, we are going to click on PM2 M3 design, which is for column. And the rebar material, so the rebar material, the longitudinal bars, if you click on this drop down menu, we need to select grade 60 rebar, because this was the rebar property we defined. So you click on grade 60 rebar, which is 60 KSI. The confinement bars, we also need to use grade 60 rebar, which is 60 KSI. Then the reinforcement configuration, this is rectangular because we are designing a rectangular column. Then the confinement bars is ties. Now for the check/design, as you can see, we have two types. We have reinforcement to be checked and reinforcement to be designed. So basically, reinforcement to be checked, if you click on reinforcement to be checked, this means that you need to provide the reinforcement in the column. So let's say, for example, if you already have a column and you already know the reinforcement that will go inside the column, so all you need to do, you just need to come here, click on reinforcement to be checked, and you can input those reinforcements. So you can input the clear cover for confinement bars, you can input the longitudinal bar size, the corner bar size and areas. So you can input all these values if you already have the reinforcement and you want to check if it is going to be able to withstand the load or not. But if you click on reinforcement to be designed, then you don't need to input those data. Etabs is automatically going to input everything. Etabs is automatically going to input this data for you, as long as you already define the section of the column. You already define the grade of rebar you are going to use, which we are using grade 60 rebar. So because we don't like to waste too much time, why not allow Etabs do the job? Moreover, this is the job of Etabs. This is going to be designed by Etabs. So after that, you just need to click on OK. Now, this is where you need to pay close attention. This is where most structural designers make mistake. This is where most structural designers get it wrong. The modifier show modifiers. So pay close attention to this. Whenever you are defining your section property, make sure you always look at the modify show modifiers. So let's click this. Now if you click this, as you can see, we have the property / stiffness modification factors. So whenever you are defining your section property, make sure you change this modifier. It is important. Most structural engineers, they don't change this. They just leave the property stiffness modification factor as 1. They don't change it, and this is wrong. And I'm going to tell you why this is wrong. Now, we know that the gross area or the cross-sectional area of a beam or column or slab before a load is applied on it is going to be different, is going to change after we apply the load on it. After we apply a load on the beam, of course, we are going to expect some cracks. Because we are going to expect some cracks, meaning the gross area before the load was applied is obviously going to be different from the gross area after the load has been applied on these structures. And when we don't have the same gross area, then the moment of inertia is going to change. So the moment of inertia about the 2 axes is going to change. The moment of inertia about the 3 axes is also going to change. And this is in reality. In reality, the beams and the columns are always going to be subjected to load. And because they are subjected to load, we are of course going to expect that the gross area before the load was applied is going to be different from the gross area after the load was applied. So let me explain this to you using the cross-sectional area of a beam. So let's say, for example, this is the cross-sectional area of a beam. And we have the neutral axis. Let's say this is the neutral axis, and we have the bottom reinforcements. So these are the rebars. Now we know that below the neutral axis we are going to have the tension zone. So this is the tension zone, while above the neutral axis this is going to be the compression zone. So below the neutral axis, concrete is weak in tension. So because concrete is weak in tension, we provide this steel rebar, and above the neutral axis, concrete is very strong in compression. So because concrete is weak in tension, meaning of course we are going to be experiencing cracks. We are going to be experiencing cracks below this neutral axis. So because concrete is weak in tension, we tend to ignore the concrete in the tension zone. So we only take the compression zone. So this is why we need to account for the gross area. We need to account for the property modifier, because now the region below the neutral axis is going to change. That is, the gross area is going to change compared to the compression zone. So we are going to use the ACI code to account for the property modifier. So if you check the ACI website, as you can see here, ACI is saying that if we are defining the section property for the beams, the property modifier is going to be 0.5 multiplied by IG, which is the gross area. So meaning we are only going to take 35% of the gross area. And if we are defining the column, we are going to take only 70% of the gross area. Then if the wall is on crack, it is going to be 70% of the gross area. If the wall is cracked, it's going to be 35% of the gross area. You can also get this from the ACI 31814 code. So as you can see, for the columns, ACI is saying that we need to take 70% of the gross area, while for the beams, we need to take 35% of the gross area. Then if we have uncracked walls, it is going to be 70% of the gross area. Then if the wall is cracked, it is going to be 35% of the gross area. And also for the slab, as you can see, flat plate and flat slab, it is going to be 25% of the gross area. So now we need to change the moment of inertia about the two axes. Instead of 1, it's going to be 0.70, which is 70%. Then also we need to change it for the moment of inertia about the three axes. So this is going to be 0.70. Now the reason we do this is because this is going to make our design very, very economical. It is going to allow us to save reinforcement. So because we don't need to account for the whole section, we don't need to account for the whole gross area of the column. So now it is going to obviously reduce our reinforcement. It is going to lead to a very, very economical design, so that we don't waste too much money on reinforcement, because we obviously don't need to account for the whole section of the column and the whole section of the beam. So we just need to take 70% into account, because the remaining parts are already cracked, so we don't need to bother about that part. So hope that is understood. So after that, you need to click on OK. We have defined the section property of the column, then you need to click on OK. So now as you can see, we now have it column 400 by 400 millimeter. So you click on OK. Let's define the section property of the beam. To do that, you need to click on the define menu. You click on section property, click on frame sections, then you click on add new property. So this is concrete rectangular. Then we are going to have a rectangular section. Click on this. So as you can see, it is still in millimeter. So for the beams, we are going to be using 250 by 450 millimeter. So the depth is always going to be higher. So the depth is going to be 450 millimeter. So this is just a trial session. So if we use this session and after performing the design and we find out that it is not going to work, it is going to fail, then we need to change and increase the session. But let's start with this session. So we are going to start using 250 by 450 millimeter. So the depth is going to be 450 millimeter, while the width is going to be 250 millimeter. So we are going to change it. So we are going to name this as beam 450 by 250 millimeter. So the material type is going to be 4 KSI concrete. Then modify show rebar. If you click on this, so instead of design type column, it is going to be M3 design only beam, because this is a beam. So you click on this. Then we need to change the rebar part material to grade 60 rebar, because we are using grade 60 rebar. So also click on this. So this is the cover. So the top cover is 63.5 millimeter, while the bottom cover is 63.5 millimeter. So it is okay, we click on OK. So we also need to change the modifier, the stiffness modifier for the beam. So make sure you don't forget this. Always change your stiffness modifier for the beam and the column. It is going to make your design very, very economical. So always do this. So as you can see, the stiffness modifier for the beam is going to be 0.35 Ig, which is we're going to take 35% of the gross area. So the moment of initial about 2 axis is going to be 0.35, while the moment of initial about 3 axis is also going to be 0.35. So that is all. We need to click on OK. So make sure you always change your stiffness modifier. Click on OK. So I think that is all. We also click on OK. So as you can see, we now have the beam 450 by 250 millimeter and the column 400 by 400 millimeter. So that is all. We click on OK. So now we have not defined the section property for the beam and the section property for the column. So this is where we are going to stop in this lesson because I don't want this video to be too long. So we are going to continue in lesson 4.